Hi, in this video I want to demonstrate how to do a hypothesis test of some population mean mu. I'm going to go into the Stat menu and then I'm going to arrow over to the Test submenu, and that brings up a list of all of the hypothesis tests you can do on your calculator. Now the first two items on the list are the ones I want to talk about, z-test and t-test, because this is where you can test the population mean mu of some normal distribution. I'm only going to demonstrate t-test in this video, but once you know how to use one of these, you'll know how to use either one. So what's the difference between the two? Well, z-test is the test you would do if you are given the population standard deviation sigma. In the more common situation where sigma is unknown, you're going to use t-test. And that's going to be the situation with the example I'm going to demonstrate in this video. So let me go over to that example now. From the Bureau of Labor Statistics, the average time spent by full-time college and university students on educational activities is 3.3 hours per day. Now, a school administrator surveys 16 randomly chosen students to see if that time has increased. He compiles the following data of the number of hours that each student estimates that he or she spends on average on educational activities each weekday, and that data is shown here. The question is, at a 5% level of significance, is the population mean time spent on educational activities greater than 3.3 hours per day based on this sample? Okay, so as I said, in the situation where the population standard deviation is unknown, you're going to use t-test. So I've got that option highlighted. I'm going to press enter. Next, you are going to input the information to do the hypothesis test. In the first line that you're prompted for is how you're going to give the calculator your sample information, and there are two ways to do it. This first option, data, is the situation where you have a list of raw data, and you might want to pause the video now and put this data into a list on your calculator. As you can see, I've already put it into list L2 on mine. Now the other situation is the stats window, and that's the situation where instead of inputting the sample data directly, you have already computed the descriptive statistics of that sample. In other words, you're given, or you have, x bar, your sample mean, and s, your sample standard deviation, and you can see in this window you would just enter those values directly without giving it any kind of list of data. Now for this example, as I said, I've got a list of raw data, so I'm going to go back over to that data option. And I'm going to go down to the next line now, which is mu naught. Now this is the population mean value of mu that you're testing. And I'm going to input 3.3 for this example. Next is the list that contains your sample data. And on my calculator, I put that into list L2. So I'm going to choose L2 here. Frequency you want to leave as 1. And then this last line is where you're going to give it the alternative hypothesis. And basically your alternative hypothesis indicates what type of test you're doing. Either a two-tail test, or a left-tail test, or a right-tail test. And this has implications about how your p-value is going to be computed. So if I look back at my question, I see that it's asking, is the population mean greater than 3.3 hours per day? And that implies a right-tail test. So I've got the greater than mu naught symbol highlighted. I'm going to press enter to select that. Next I go to calculate and enter. And let's take a look at the output. The first line is a restatement of that alternative hypothesis, that mu is greater than 3.3. Next I have the test statistics. So if you're doing a classical type of hypothesis test, this is the value you would use on your graph to compare to the critical values. Below that, I've got the p-value, which reads 6.33 times 10 to the negative 4. So let me caution you about something here. The p-value is a probability, and probabilities can never be greater than 1. So when you look at your p-value, if it looks like it's greater than 1, look all the way across, because the number's actually in scientific notation, and you've got this exponential bit tacked onto the end of it. So it looks like it might be a large value, but in fact it's actually a very small value in this example. Let me go on. X bar would be the sample mean that it computed for the raw data, and S, the sample standard deviation, and finally the number of data points. Now let me talk about that p-value again briefly. As I said, in this case, in this example, the p-value came out in scientific notation because it's such a small value. So what that looks like in decimal notation is this. I'm going to round it a little. That's actually what the p-value is, and if I enter that small value, it's going to repeat it, but in scientific notation, which pretty much matches what you see here. So you can see the p-value is actually 0.0006. Now you're going to compare that value to alpha in order to make your decision about the hypothesis test. And since the p-value is less than alpha, which is 0.05, we are going to reject the null hypothesis, and we can conclude that there is sufficient evidence to conclude that the population mean time spent on educational activities is greater than 3.3 hours per day. Okay, so that's basically how you can do a hypothesis test on your calculator of some population mean mu. There was a couple other things I'm going to show you really quickly. As I said, z-test works much the same way as t-test. One additional thing is that it will prompt you for sigma, as if sigma is known. Now, if sigma is not known, then that should tell you you're in the wrong window and you need to go back to t-test. And let's go back to t-test, and there's a draw option, which is kind of a convenient way to get a visual representation of your p-value. So let me show you what that looks like. You'll want to make sure that your stat plots are all off. So you can see here's the stat plot window, and they're all turned off. And also make sure that your y equals menu is off as well. And if I click draw, this is going to bring up the t-distribution curve for 15 degrees of freedom. Remember that my sample size is 16, so that corresponds to 15 degrees of freedom. And in this case, there's nothing shaded. That's because this p-value is so small and so far out into the right tail that it really doesn't show on the screen. In a situation where your p-value is larger, what you're going to see is some portion of the curve shaded to represent the area that corresponds to the p-value, and then that will also indicate where your test statistic lies on the curve. Okay, so that's kind of a nice visual representation of the hypothesis test. So basically that is how you do hypothesis tests of population mean values mu.